All right, so I want to show that every convergent sequence in any metric space is automatically Cauchy. And so the way that we're going to do this is we're going to begin by assuming, so let's say assume that P sub n is convergent. And since it's convergent, it has a specific limit, let's say P. So we'll say that P sub n converges to P. Okay, so the sequence converges to P. So now, to show that it's Cauchy, I need to choose an epsilon. So I'm going to say, all right, choose epsilon bigger than 0. Now I'm going to say, okay, since it's convergent, there's a cutoff point that puts every term in the sequence within epsilon of P. So I'm going to write that down. So I say, since P sub n converges to P, there exists an n such that if little n is bigger than or equal to big N, then the distance between P sub n and P is less than epsilon. Now, I can do epsilon if I want. I, for my own purposes, want to do epsilon over 2. As long as what I put here is positive, I'm good to go. And I want you to make sure that you understand this part has nothing to do with this unless we want it to. Just since it's convergent, there's a cutoff point for any positive number that you want to put there, as long as it's positive. The number that I happen to be interested in is the epsilon that was chosen for this other thing cut in half. Okay? So then here we go. So next I'm going to say, okay, so let's say thus, if n and m are two indices past the cutoff point, m is just another arbitrary index past the cutoff point. You've got this, think of the dots on this row as the sequence. Here's your cutoff point. Maybe the first one you pick is n, and then pick another one out here and call it m. Doesn't matter if the order is reversed, m can come first. They're just 2 points past the cutoff point. So if you pick any 2 points past the cutoff point, I can apply this line to both n and m. I can say, okay, then I know the distance between P sub n and P is less than epsilon over 2, and in particular the distance between P sub n and P is less than epsilon over 2. And now, hopefully you've done enough of these to sort of see the triangle inequality here. So in particular, the distance, we want the distance between P sub n and P sub m. This is certainly less than or equal, use the triangle inequality, P sub n and P, plus the distance between P and P sub m, and this is exactly less than epsilon over 2 plus epsilon over 2, which is epsilon. So we've got the cutoff point for Cauchiness, and we've got everything beyond that cutoff point squeezed less than epsilon. We're done. So we can say, thus, P sub n is Cauchy.